Okay, let's dive into the world of Spring performance, but we're going to look at it through a very specific lens, the technical interview. So picture this. You're in a high-stakes interview for a senior Java developer job. You've nailed the basics, you've talked architecture, and then the interviewer leans in. They're about to ask the questions that really separate the candidates. They want to talk performance.
And here's the thing. For senior roles, the conversation almost always shifts right here, to Spring Boot and microservices. See, they're not just checking if you know the syntax, they're digging deeper. They want to see if you understand the massive performance impact of the code you write, especially when it's part of a huge distributed system.
So what's the difference? What separates a good answer that says, yeah, I can use Spring Data JPA, from a great answer that says, I know how to make Spring Data JPA fly? Well, it really comes down to knowing how to avoid a few super common but really critical performance traps. So let's break them down.
First things first, we have to talk about the absolute foundation of any performance tuning. And it's a simple idea. You can't fix a problem that you can't see. This is where so many issues start, or more accurately, where they go completely unnoticed until it's way too late.
You know, the number one pitfall happens before you even write your first bit of logic. It's the simple failure to actually watch what your application is doing to the database while you're building it. That tiny little inefficiency that's totally invisible on your laptop can and will explode into a massive bottleneck in production.
So, the mission is to make the invisible visible. And honestly, the solution is surprisingly easy. By just adding these couple of lines to your configuration, you're essentially telling Hibernate, the engine running under the hood, to show you everything. It'll spit out every single SQL query it runs and give you a full statistical report. Suddenly, you have X-ray vision into your database interactions.
Okay, so now that we have our X-ray vision turned on, let's use it to spot our next big problem. Those common coding habits that seem totally harmless. You know, the classic it works on my machine scenario, but cause total chaos under a real load.
Let's start with a classic. You grab a list of things from the database, you loop through them, make a change to each one, and then you call save and flush inside that loop. I mean, it seems logical, right? You change something, so you should probably tell the database to save it. But that's a huge misunderstanding of how JPA actually wants to work.
Now, let's look at the damage. If you have a list of, say, 4 players, that innocent-looking little loop results in 5 separate flush operations. Yeah, 5. Every time you call save and flush, you are forcing Hibernate to stop, scan everything it's managing, and sync up with the database. It is incredibly inefficient.
The fix, the right way to do it, is to just trust the transaction. It's actually simpler. See, any object you've pulled from the database is already being managed. JPA is watching it. So all you have to do is make your change. That's it. Just change the object. JPA will automatically bundle up all those changes and send them to the database in one clean, efficient batch when the transaction is over.
And the result? Instead of 5 flushes, you get 1. Just 1. A single optimized operation that handles all 4 updates at the same time. This is the huge difference between fighting the framework and working with it.
All right, let's move on to another huge interview topic, and maybe one of the most famous performance problems in the JPA world, the N+1 select dilemma. This all comes down to how you grab related data.
You basically have 2 main choices. There's eager fetching, which grabs all the associated data right away. It's simple, but it's often like ordering the entire menu when you just wanted a cup of coffee. Super wasteful. So the common advice is to switch everything to lazy fetching, which only gets the data when you ask for it. But is that really the solution?
Well, not quite. By defaulting everything to lazy, you've just swapped one problem for another one. And this new one is way sneakier. You've basically just set a trap for your future self.
And that trap is the N+1 select issue. Here's how it plays out. You run one query to get, let's say, 100 blog posts. That's the one. Then, as your code loops through those posts and tries to access the comments for each one, JPA has to go back to the database 100 separate times. What looks like a simple loop in your code unleashes a storm of queries on your database.
So the real pro move is to be specific. The best practice is to default all of your associations to lazy. Then, for the specific methods where you know you're going to need that extra data, you use an @EntityGrab annotation. This is you telling JPA, hey, for this one query and this query only, please be smart and grab the posts and their tournaments all in one efficient trip. It's the best of both worlds.
Now, let's tie all of this back to that bigger picture we talked about, microservices. Why do interviewers for senior roles care so much about these little database details? Because in a microservices architecture, small problems don't stay small. They get magnified.
Exactly like the mock interview points out, in a distributed system, all bets are off. You can't rely on anything. Your different services are all talking over a network, and the network is always going to be slower and less reliable than talking to something inside the same machine.
And this is what happens. That N+1 problem we talked about, it's not just a little database hiccup anymore. Now it's N+1 slow, painful network calls bouncing between your services. And one slow service can create a chain reaction, a cascading failure that brings down other parts of the system. Your ability to scale your entire application is now held hostage by your single worst-performing part.
So the next time you're in that interview or even just writing your next piece of code, ask yourself this question. Is my code just working, or is it actually performing? Is it efficient? Is it resilient? Is it ready to scale? Because answering that question correctly, well, that's what separates a good developer from a great one.